Hello and welcome to the course Climate Hazards and Disaster Mitigation. Today we are beginning a new module where we will discuss in depth about heat waves and cold waves, that is temperature related extremes. In this lecture we will begin our discussion with heat waves, its causes and drivers. So the learning objectives are: we will define heat wave and explain the criteria to identify heat waves as per the meteorological standards. We will analyze the major causes and climatic drivers responsible for heat wave formation and intensification, and we will assess the physical, environmental and societal impacts of heat waves. What is heat wave? So a heat wave is a period of abnormally high temperatures, more than the normal maximum temperature that occurs during the summer season, particularly northwestern and south central parts of India. So whenever we say that, or we experience that the temperatures have overshooted a certain range, then the meteorologists will declare it as a heat wave. So typically heat waves occur during March and June, and in some rare cases it extends till July. You would be surprised to note that heat waves are not only limited to land surfaces, but there are some specific marine heat waves also, which the ocean bed also experiences some changes in the heat content, and they are called marine heat waves. But here we are mostly focusing on the land surface heat waves. So this extreme temperature and resulting atmospheric condition during the heat waves, they very significantly affect the physiological stresses, and sometimes they can cause fatalities as well. We first discuss the IMD criteria for defining heat waves. So as per India Meteorological Department, heat wave is considered when the maximum temperature at a station reaches at least 40 degrees Celsius for plains. So if there are plain regions, relatively flat topography, it is 40 degrees Celsius, at least 30 degrees Celsius for hilly regions. So if there are hilly regions, the threshold is bit lower, and it is at least 37 degrees for the coastal region. So these are the thresholds, absolute thresholds, which define heat waves. So you can take absolute threshold of maximum temperature to define the heat waves. If we recall our earlier discussion on extreme temperature and rainfall indices, there we categorize that T max is the maximum temperature and T min is the minimum temperature, which we get from the IMD. There is another criteria: when the normal maximum temperature of the station is less than equal to 40 degree. Let us say the temperature is less than 40 degree, then heat wave is considered if the departure from normal is 5 to 6 degree. Now here what do you define normal? Normal is the average temperature for past 30 years. So here we are talking about T max. When we talk about heat waves, all our temperature will be restricted to T max. So for example, on 1st June, the average T max at a given station was 37 degrees Celsius, and that is a normal. Now we find that on a particular year, so the average temperature went to 44 degrees Celsius. Then we can call it that there is a departure from normal around 5 to 6 degrees Celsius. It is referred to as a heat wave. Similarly, again, if there is a severe more than 7 degree, it is called a severe heat wave. If let us say this threshold is less than that, its threshold is 30 degree for a plain, and it exceeded by 5-6 degrees like 36 or 37 degree, then also it will classify as a heat wave, because a departure is very significant from the normal. If the other case, when your temperature at a station is more than 40 degrees Celsius, then just 4 to 5 degree Celsius departure from the normal is considered as a heat wave, and 6 degree Celsius more departure is considered as a severe heat wave. Now if the actual temperature is 45 degree or more, irrespective of the normal temperature, the heat wave has to be declared. So there are multiple criteria which define the declaration of heat waves. So here we are summarizing those criteria: 40 degrees Celsius in plains, 30 degree in hills, and 37 degrees Celsius in coasts. And then the departure from normal when heat wave condition prevail or severe heat wave condition prevail, as we discussed in the earlier slide. If it is 45 degree, irrespective of the normal, it is heat wave, and 47 degree you call it as a severe heat wave. Again, the same criteria has been listed. There is one more thing, that there is a duration requirement also. So heat wave is usually a continuous phenomena. So if these conditions persist for at least 2 consecutive days and affect at least 2 stations in a subdivision, then you declare that it is a heat wave event. Otherwise it can be an anomalous event, that one of such event happened and then it subsided. But if the duration requirement is met, then you declare it as a heat wave. So heat wave has to be declared. So when heat wave is declared, there are several protocols in place, that people are advised not to venture out, and some essential services are kept, then like school, colleges will be shut down. So these are some protocols in place. Now apart from this absolute, there is an other criteria which is a percentile based criteria. Now why this percentile based criteria is important? Because absolute criteria would treat all places as equal. For example, there are 2 different places, X and Y. So if I apply 40 degrees Celsius criteria, it may treat both the things alike. But if I keep another criteria like 90th percentile, then this 90th percentile will have different individual value for X and different value for Y, and all T max exceeding T 90th percentile threshold we can quantify as a heat wave irrespective of their geographical location. So when you want to compare 2 different regions, the percentile based criteria is more preferred as compared to the absolute criteria. So if we consider 90th percentile criteria, then we define heat waves as a threshold for 90th percentile. So where your daily maximum temperature exceeds the 90th percentile of its long term climatology, that is a 30-year, that is a baseline. So whatever baseline you suggest, so the exceedance must persist at least for 3 to 5 consecutive days. For example, if the 90th percentile for Delhi is for May is 41 degree, and any day above 41 degree contributes to a heat wave spell, provided it should be consecutive at least 3 days. Some studies have also proposed 95th and 99th criteria for extreme heat waves. So that is similar to the 90th percentile criteria, that it should exceed this defined threshold. So percentile based thresholds have a relative advantage over absolute threshold. Coming to the heat wave prone region, so you can see this map which is taken from this website. So although it is showing in Fahrenheit, that is from NOAA Climate, but if we convert into degree Celsius equivalent, so we can see that this entire region in the northern belt of India and some parts of the central and eastern parts, so these are prone to very severe heat waves. Here some place in the coastal belt as well. So this is the heat wave prone region in India. So entire northern belt, parts of the peninsular and eastern belt. So sometimes you can see these coastal regions of Andhra Pradesh and Tamil Nadu, they are also prone to heat waves. So these regions are very susceptible to heat wave occurrences. Now how does IMD provide a warning about the heat wave? So it has 4 different levels, starting from green, yellow, orange and red. So green, that is no action, that is normal day, temperatures are clear, so it is more comfortable and there are no health risks, so it is green, so it is business as usual. Yellow, so there is a heat alert, that heat wave in some isolated pockets are observed, not uniformly but 1 or 2 regions. So there is moderate heat but which is tolerable, and there is risk for some vulnerable groups, like there are infants, elderly people or those who are chronically ill. For them it is suggested that you take precautionary measures. So there the actions will be avoid heat exposure, then wear light color clothes, then cover your head with cloth or umbrella, that way. Next is orange alert. You might have heard this orange alert. So orange alert is that severe heat wave, what we define as greater than 47 degrees Celsius or more than 95th percentile, persists for 2 days, or a normal heat wave persists for more than 4 days. This is a severe heat wave alert, and you have high heat, very high risk for illness, and outdoor workers and vulnerable people are to be cautioned here. So then there are suggested action which are more of a mitigation measure, that stay cool, avoid sun exposure, drink water, stay hydrated and all. Red, then we come to red. So here you have to take action, because this is very severe, where your severe heat waves persist for more than 2 days, or a regular normal heat wave persists for more than 6 days. So you can have a very high risk of heat strokes and heat illness for all age groups, and everyone is vulnerable, and those people with chronic illness are more vulnerable. So you have to limit outdoor activities, strict precautions, and stay more hydrated. So what are the drivers of heat waves? So climate change is one of the drivers, where global warming is intensifying the temperature on the earth, which is accelerating the heat waves. They are becoming more frequent and more intense. Meteorological factors like high humidity, low wind speeds can also exacerbate heat wave, and duration, that if the hot spell persists for a longer time, that can also cause heat waves. So looking at the drivers, if there are high pressure systems, so they drive more warm air, and that can result into heat waves. Greenhouse gas emissions, cyclones and anticyclones can also cause, because they are formed due to low pressures. Cyclones and anticyclones are opposite to that, so that alternating low high pressure cycles and also cause heat waves. El Nino, particularly in the Indian subcontinent, are related to heat wave occurrences. If there are landscape changes, that means deforestation on large scale, then can cause heat waves. And depletion of soil moisture, that results in drier condition, that is losing the cooling of the ground, that can also lead to higher surface temperatures. What are the causes and influencing factors? If usually a decline in pre-monsoon rainfall is associated with a high heat wave risk. So at many places you can see scattered pre-monsoon rainfall, which lowers the land surface temperature. However, during recent decades, this pre-monsoon rainfall have become less frequent and less intense, and that has escalated the heat wave frequency. Large parts of the country remain dry and moisture deficient during March to May. That adds up, because this dry soil will heat up more quickly, and then it results into extreme heat wave conditions. Next is role of global warming. So although heat waves are regional phenomena, their intensity is rising in the backdrop of global climate change. There are projections which say that the earth temperatures have risen 1.5 to 2 degrees as compared to the as compared to the 1870s, and these elevated temperatures are causing escalated heat phenomena. Link with El Nino events. El Nino are often associated with stronger heat waves in India, because warmer waters in the central and eastern Pacific, they disrupt the monsoon circulation, they cause reduction in pre-monsoon rainfall, they delay the onset of monsoon, and drive more hotter and drier conditions over the subcontinent. Warming of the Indian Ocean is again, which is a phenomena which is being recently brought into attention by the researchers, because the Indian Ocean has been heating at a faster rate as compared to the Pacific Ocean and other oceans. So this rise in the temperature will alter the moisture transport from ocean to land. With less moisture reaching the Indian mainland, there is an increase in the dry spells, higher temperatures are observed, which intensifies the heat waves. Again, these things are coupled with human activities like deforestation and urbanization. They will again result in the higher severity of heat waves. Next is the human induced factors. As we discussed, deforestation, reduction in the vegetation cover, and cutting down on the evapotranspiration, which leads to cooling of the land surface. So this part is being eliminated by cutting our forests. Rapid urban growth. We are making concrete jungles which reflect or emit which store and emit more heat. So the urban heat island effect grows, and cities and the surrounding areas are becoming more hotter. Due to industrial and vehicular emissions, the air pollution levels are rising, and that is also causing prolonged heat episodes. What are the impacts of heat waves on health? So initially you will get heat cramps, you will get exhaust very quickly, you will exhaust due to heat, and ultimately heat stroke. You will feel ill, you will fall ill, and then you will have a fever and other things. So if heat cramps, you will cause you fainting and fever less than 102 degree Fahrenheit. Heat exhaustion would cause fatigue, weakness, dizziness, headache, nausea, etc. And heat stroke, where your body temperature will be greater than 104 degree, and you will cause seizures. An extreme condition can cause coma, or it can be fatal also. So these are some of the events that there will be rashes, there will be nausea, dizziness, vomiting. So what you need to do, you need to slow down, take a break and recover yourself. And if there is a heat stroke, then you should immediately seek hospitalization. Now, how do warm nights or high minimum temperatures affect humans? So this increased heat stress, usually our focus when we talk about heat stress is the maximum temperature. We always think that Tmax will cause heat stress, but there is a silent killer in T minimum, particularly during night time. So many a times we observe that the nighttime temperatures are also not cooler. So nighttime also there is sustained warming. So that prevents the human body to cool down and allows very less recovery time from the heat which we gather during the day. So the heat stress goes up. Also warmer nights are reduced to sleep disruptions because of the uneasiness and discomfort, and that can also affect the physical and mental health. Also the people who are prone to cardiovascular diseases, they will worsen their condition because of acute heat stress which cause discomfort to the patients. There are aggravated chronic conditions like when there is higher temperatures at the night, if there are pre-existing ailments, particularly due to cardiovascular, respiratory and diabetes related conditions, they will be aggravated. The constant heat exposure can also impact the mental health by increasing anxiety, depression and other conditions, and insufficient sleep can reduce the cognitive performance of the body and reduce the productivity and weaken the immune system as well. What are the physical impacts? Because climate and water are very closely related to temperature, so heat wave, if it intensifies, it could cause water crisis in many regions, particularly arid and semi-arid regions. We also saw in previous lectures that the wildfires, because of heat waves, where soil is very dry, it acts as a driver for wildfires, because that is a precondition. Drier soils accompanied by lesser moisture and then heat waves just put in, so they will trigger the wildfires. Due to heat waves, the temperatures are so high that your energy consumption is very significant, and due to that there are power outages if the energy needs are not met. Impacts on agriculture: higher temperatures beyond a certain optimum level, they will reduce the plant growth, because plant requires an optimum temperature to flourish and grow properly. So if the temperatures are not conducive, then they can experience heat stress. Livestock, again, number of physiological and behavioral responses are seen in livestock. They vary depending upon the genetic makeup of the animal and the environmental factors. Poultry, if the heat stress interferes with the broiler's comfort, they suppresses their productive efficiency, growth rate, and then also causes immunological deficiencies in them. Heat waves can affect the fisheries and aquaculture via acidification, changes in the sea surface temperature and circulation patterns, and they can have large scale ecological implications. They also affect the transport and infrastructure, like higher temperatures will reduce the air density, and that would exert extra pressure on the aircraft engines and to generate thrust and lift. As a result, your planes would require longer runways to take off and may face restriction on payload as well. This effect is compared to flying at higher elevation. For example, if your airport is at sea level and outside temperature is 37 degrees Celsius, that conditions will be equivalent to operating at a level of 800 meters or above, because with rising temperatures the air density reduces, and that will also cause changes in the pressure, and that would cause changes in the meteorological conditions which are favorable for landing and takeoff, and that can affect the air operations as well. If the air temperatures are too severe, sometimes the air traffic is also brought to an halt. Extreme how they affect transportation infrastructure: extreme heat causes pavement and asphalt surface to soften, and sometimes you can see there are pavement cracks also being developed. Due to continuous vehicle movement, it leads to rutting, cracks of pavement, and also cause structural damages. In rail tracks, they undergo thermal expansion beyond their permissible limits, and they can also cause buckling of tracks, which can cause rail accidents. Heat waves as an hazard. So these are the figures compiled from 1900 to 2011. So you can see, as compared to, so each represents 100 deaths. So as compared to landslides, lightning, then next is bushfires, that is wildfires, then flooding, cyclone. So you can imagine how many times more extreme heat is causing deaths as compared to all other natural hazards. So extreme heat is one of the most severe hazard which is being observed. Now if we compare the stats for India, we can see that from 1992 till 2024, these are the recorded heat deaths caused by heat waves. So 1998 was the highest, where more than 3,000 people were fatal in the heat waves. Then 2014, 2015, and recently 22 and 23. So you can see that the amount of person being affected or fatalities caused by heat waves is rising many folds, and it is becoming more frequent in the recent decades. Future prediction of heat waves. So the climate models and reports from IPCC AR6 will have indicated a significant increase in the heat wave risk. So there is increased frequency in the duration, as well as the intensity of heat waves globally. There is a higher probability of extreme events. With 1.5 degree of global warming, heat waves used to occur once in every 10 years, and now they will occur over 4 times more frequently, and 10 times more frequently with 4 degree warning. So where the heat waves were once in 10 years, now they are occurring 4x more quicker for 1.5 degree warming, and 10x more quicker for 4 degree warming. So that is the alarming level which we have reached. Disproportionate impacts. Regions like Indo-Gangetic Plain and coastal areas are at higher risk due to combined effects of rising temperature, high humidity, and population. So we often consider temperature to be the main villain, but humidity is again more responsible for these things. So these humid conditions will cause frequent dehydration as well. Warmer nights. Nighttime temperatures are projected to rise faster than daytime temperature, and in many areas, which is especially dangerous for human health, as it prevents the body from cooling down. And again, severity depends on emissions. The magnitude of future changes depend on current actions. Aggressive emission reductions could slow the increase in heat extremes, but without immediate action, the world could see global temperature to rise 2.5 degree or more by the end of the century. So if we do not cut down our emissions, then this is a scenario which is threatening, and that can have large scale ramifications. What are our key takeaways? So we understood that there are different thresholds, that is absolute and percentile based thresholds, to categorize heat waves depending upon the topography. That is 40 degree for the plain areas, 37 for the coastal, and 30 for the hills. Decline in pre-monsoon rainfall, global warming, changes in oceanic atmospheric circulations, deforestation, urbanization are the major causes of heat waves. Heat waves result in multifaceted impacts related to environment, energy, infrastructure, and health sectors. An activity suggestion for you: check whether your state is prone to heat waves or not. If your answer is yes, then how many years in the past, based on the available record, has your state experienced heat waves? You can document those years. So you will get several reports where this documentation will be there. You can just compile it. Some additional learning resources. This is a very good research article on phenology of heat waves over India, and this is a IMD monograph on heat and cold waves in India. That is also a good compilation for you to refer. So thank you for your attention. We'll meet in the next lecture to discuss estimation of heat stress.